So in part 11 we discovered a method for factorising difficult quadratics, which we're now going to practice. I'm going to start with 3x squared plus 5 on the end. We'll put 8x here. Now, our method we discovered was as follows. The two numbers multiply to make 15 and they add to make 8. What are the pair of numbers? Well, hopefully you can see they are 5 and 3, which means our 8x is going to split into 5 and 3. Now, factorise the first pair. In fact, you can probably even look at these and see it's going to work. That takes an x out and leaves 3x plus 5. And the second pair, this is an interesting one, this here is one lot of 3x plus 5. So we have x lots of this and one lot of this. So we have x plus 1 lots of that. Nice and easy there. And hopefully the hard work you did in understanding why this is the case will make this much easier. The next one's going to start with 4x squared and going to have 6 on the end. It's going to be 11x in the middle. So here we go. Two numbers multiply to make 24 and add to make 11. Okay, 8 and 3. 4x squared plus 8x plus 3x plus 6. First two have 4x in common, and it gives you x plus 2. Second two have 3 in common, and sure enough, x plus 2. 4x plus 3, lots of x plus 2. Remember to pause the video and try the question for yourself at any point you feel you need to. So the next one starts 6x squared and ends with 16. So here already, remember, if this had been with the old trial and improvement method I suggested, you would be panicking going, uh-oh, this could take quite some time. Hopefully for us, it's going to be easier than that because we have a method. So here we go. Putting 35x in the middle. By all means, pause if you wish to try it for yourself. So, the two things multiply to make what? That should be a 9 because it's 6 times 1 is 6, add 3 makes 96. So they multiply to make 96. They add to make 35. Okay, so 96 is 1 and 96, 2 and 48. Now to make 35 when they add, one of the numbers is going to have to be quite big. Is this in the 3 times tables? Well, yes it is, because both divide by 3. 3 and 2, 32. Aha, found it. So, 6x squared plus 3x plus 32x plus 16. Now, 5 and 3, 8 and 3. 3 and 32. You'll notice the first two, the larger x went first, and here I've switched it. That's because it doesn't actually matter. And in this question, I'm going to do it both ways round to prove that point. So, factorise these first two that have 3x in common to give you 2x plus 1. The second two, both in the 16 times tables, to give you 2x plus 1. So you have the brackets then, 3x plus 16 and 2x plus 1. Now if we try it the other way around, so what do they have in common? Well, they have an x in common and they have a 2 in common. So that leaves me with 3x here plus 16. Should look familiar now. Plus 1 lot of 3x plus 16, which gives me 2x plus 1 and 3x plus 16. And it doesn't matter which way round the brackets go, because it's two things multiplied together. 3 examples there, all with positive numbers. Now negatives aren't going to make a difference, but perhaps we should try one in a second. I want you to realise at this point that as long as you are careful with your working out, you will be fine. So, 12x squared minus 41x plus 35. If you want to try it for yourself, pause the video and then watch through afterwards. So, the two multiply to make whatever 35 times 12 is. So that's 2 times 35 is 70, and 10 times 35 is 350. So it's 420. They add to make minus 41. So we're dealing with some negatives here. Now, the fact they multiply to make a positive, but they add to make a negative, suggests that one of them is going to be, or both of them are going to be negative. So let's see what happens when we do this. Okay, 420. So if I list some positive pairings first, this could take quite some time because I've deliberately picked numbers that are quite factor heavy. No, 8 doesn't go into it, neither does 9. 10 does 11? No. 12? I know 12 does, and I'll show you how. If I double 6, I get 12. So if I half 70, I get 35. So if I double 7 and half 60, I get another one. If I times 5 by 3, I get 15. And I divide 84 by 3, I get 28. This only works if both numbers come out as integers, but it's a very quick way of checking. Let's check 16 times that by 4. Well, you can't divide 105 by 4, so 16 is a no. So, got quite a lot of pairs here. Let's go a bit further. 17, no. 18, So times 6 by 3, divide, no. 20, yes, and 21. We can't go past 21 because we've already got those numbers here. In fact, this pair here is crucial. They multiply to make positive 420. They add to make minus 41. So our pair are here. So let's now use our pair and get our answer. Apologies for the camera in this video, it seems to want to fall all over the place. So 20 and 21. So these two have a 4 in common and an x. That leaves 3x here, minus 5 here. These two have a 7 in common. Now, I need the bracket to say minus 5 and the bracket to say 3x. And I've got minus 21. So I'm going to take 7 out here. So I can put 3x here to make that, which means I can put a minus here. So let's go through that again. I want minus 21 here to give me 3x here in the bracket because it has to match here. So I take minus 7 outside. If the sign ends up wrong, what you do is you then take the minus out afterwards and change the signs of everything. So there we have it, a method that will work for factorising quadratics where the first number is not 1, where the coefficient here is not 1. But you will need to practice this.